The lesson 6B, where we're looking at the properties of the OOP. So the first property we'll look at here is encapsulation. Now, for you guys also be able to understand encapsulation is about hiding details and only exposing what is necessary, right? So it helps in organizing and protecting data. So the key idea of encapsulation is all about um, protecting your data. And you can see these data we call the attributes like the name, age, sound are the attributes, right? Or you can call them the data. So the key essence is protecting them. And how we can protect them is by using a private method. So you can, in the previous lesson, I say the double underscore like this, the name of the attribute shows that that particular attribute is being protected is private, right? So you can see that this double underscore name, double underscore age, and double underscore sound, they are private, which are encapsulated. Now, for us to be able to have access to this data, we need to write a function, a get function to get the name, age, and sound in order to show so that we can be able to access this private data in other classes, right, or publicly. So you can see this is a good example of encapsulation. So what we need, I need a function called like def. So I will need a function like called get name, right? So now what this get name does is it return the protected data, which is self dot the name. So I'll have another one called def get age. So what this does is it will return self dot the age. Then have another function called def get sound. So what it does is it return self dot sound, right? So now this is a good example of encapsulation so that we can be able to access this private data in our subclasses, right? So now we have a class called animal, which is our parent class, and we have a constructor here where we define the attributes for the animal, which is named a sound. And now these attributes are private data, which shows encapsulation, and these are the methods to be able to have access to this data where we're returning the data, and we're going to be using that in our subclasses. So now we have a subclass called cat, which is inheriting, which we would inherit, which we are inheriting these methods here from this our parent class called animal. So that's why we have a class cat, and then inheriting that's why we're passing the class name here as a parameter here in this class here, right? So that's or pass it as an argument right here, which is animal, right? We are passing it as an argument, so it's like this is how we inherit functions or methods in Python. So now we have a constructor. This class cat has a constructor which has a name age, right? So this one is inheriting the constructor from this parent class. That's why we're using the super function the init, which inherits all the attributes in the parent class, right? So it's the constructor. That's why we're using the super, right? So now we can have, let's say we have a function called describe, right? A function called describe. So now this describe, instead of returning the self.name, what we do is based on we have inherit all the methods from our parent class. So we use, because this is private, right? So we can have access to it here. So we use get name to have access to the name of the animal, and then we use get sound to have access to the name of the animal. Because this name, we can have access to the data here because they are made private, and we have set a get method to get name, right, to be able to have access to the private data. We have set a public method here which we have access in these our subclasses because the subclass is inheriting from the parent class. Now let's use this. So if we go to the test.py, right, so I have my cat, so I have my cat as a variable, right? So I can have my cat class here. So the cat class have three attributes, which are the name and the age and the sound, which are already passing arguments here, right? I'm passing arguments within the parentheses here. So if I print cat.getName, it will actually print this for me. Sorry, cat does not get name. The function is describe, right? Describe. So it will print this. So when I run this, now the cat is making a mew sound, right? So you can see what happens, right? You can see what happens. So we have understand encapsulation and we have understand inheritance. What we're going to be looking at is in more detailed form when we start looking at the PowerPoint slide of how inheritance works. So, but the basic thing we have understand encapsulation, but the key point is private attributes that are inside the object is hidden and protected using the double underscore, which I've shown you guys. So now let's look at the next one, which is abstraction. So abstraction is all about hiding complexity and exposing only the essential details of an object or system. So it focuses on what an object does rather than how it does it. So Python provides the abstract base class module, right, to implement the abstraction. Now to implement abstraction in Python, which in the code you can be able to understand it better. So let's go to the OOP.py. Now to implement abstraction in Python, all we need to do is to import the abstract base class module, right? Which to import that we use from the ABC, right? Import abstract base class, then import the abstract method. Right. Now I want to make this class animal, which is our parent class abstract method. So all I just need to do is to have a parenthesis like this and then pass in the abstract base class here, right? So I pass in the abstract base class which I've imported, I pass it here within this parenthesis here. So now what I will do here now is have made this the abstract class, right? So every animal, now the reason for creating the abstract method is every animal have similar method, right? Like for instance, cat and a dog can run, right? Cat and a dog can make sound. Cat and a dog can what? Can walk, right? So you can see that the cat and the dog animal has similar function, right? But different ways of organizing, different ways of performing that particular function. That is where abstraction comes into play, right? So now we have understood encapsulation, which making this private, right? So we need to we wrote a method in this parent class to be able to have access to the private phone data. Now, to write an encapsulation, to write abstraction here, we need to have the abstract method, right? Decorator. This decorator, this abstract method, right? So now there are similar things animals can do, which is they can animal walk, which means they can walk, right? Self. So let's use pass. Then another thing they can do is let's use an abstract method. Let's use animal can make sound, animal sound, for instance, so self, then pass, right? So now these are the things each animals can do, right? So now you can see that we have two abstract class here. That means for every subclasses that we're inheriting from the parents class, we must define these two abstract class for every animals, right? We must define this. If not, it will return an error, right? Even if I define a method for animal walk within the subclass here and I didn't define a method for animal sound inside this class, it will return an error. So that is the advantage of abstract class because an abstract class here, I can create a class for cat and I can also create a class for dog, but both of them actually have the same, both of them can walk and both of them can make sound, but the way cats make sound is different from the way dog makes sound, and the way dog walk cats walk is different from the way dog walk, right? So now let's do something here. So we have the cat, right? So this is the super, we have explained this. So this is the describe, right? This is the describe. So now let's write another function. Oh, sorry. Let's write another function. So because we need to write function for animal walk and animal sound. So now let's write the function def animal walk, right? So animal walk, let's use self. So return the self dot name walks like a cat, right? Because when a cat, so Saturn's name walks like a cat, just assume that this is a function for animal walk here, right? So now let's do for animal sound. Okay, let me just show you something. Let me don't do for animal sound and see what happens, right? Let me don't do for animal sound and see what happens. So if I go to my test.py here, right? So let's call this function animal walk and let's see what happens. So this is cat, then animal walk. So if I run this, now it's telling me it can't instantiate abstract class cat without an implementation for abstract method animal sound. You can see what I just explained now. You can see the reason for this because we have defined the abstract class. We have two abstract class in the parent class like animal walk and animal sound. That means every subclass is like cats where we define a class again for dog and a class again for any other animal that wants to define, right? So each of them must perform this method, right? Each of them they have the different way of performing, but they must perform this method. That is reason for that abstract class, right? So you can see the difference between abstract class and encapsulation, right? So now this is animal walk. So I need to have another function here called animal sound. So this is self, right? So what I will do is I will return. This is a format. Let's use the self dot sorry the self dot sorry get name, not name, right? So self dot get name sound animal sound. So self dot get name is making, or self dot get name makes self dot get sound, right? So now I have defined the two functions for the abstract method which are defined here. So they must exist within the subclasses. Please take note when you define an abstract class like this and you are defining a subclasses like this, which is inheriting from the parent class that has the abstract class, the method must exist within the superclass, and that makes it abstract. That is the abstraction we are talking about here. So now if I go to the tested part here, animal.walk. So if I do this now, it will actually work. The cat walks like a cat, right? So if I change this, okay, let me don't change it. Let me just print another one. Animal sound. Right? The cat walks like a cat and the cat makes meow sound. You can see what happens, right? Now we have understood abstraction and we have understood encapsulation. So the next one we'll look at here The next one we'll look at here is inheritance, which I've already explained where our subclasses is inheriting from our parent class. So let's just get definition. Inheritance is a core concept in object-oriented programming that allows a class called a child class or subclass, which I've shown you guys, to inherit attributes and method from another class called the parent class or superclass, right? So this promotes code reuse and make programs more modular and organized, right? So now in type of inheritance, we have the single inheritance, a subclass inherit from one parent class. Then we have multiple inheritance, a subclass inherit from multiple parent class, right? Which is possible for a class to inherit from two classes, right? Then multi-level inheritance, a subclass inherit from a class which is itself a subclass of another class, right? I'm going to be showing you guys these examples in other lessons, right? So let's just understand inheritance, a single inheritance here. So in this OOP here, right, you can see that we have the animal here, and this is the parent class, and you can see how we inherit. This is a subclass called the cat, right? So we have inheriting by passing the animal the class name, right? So when we are defining this cat class, we're passing the parent class called animal, and every function within this animal is being called in here. You can see how we inherit this method, right? How we inherit this method from this parent class. So this is what we call inheritance, right? This is what we call single inheritance, right? This is what we call single inheritance here. So let's look at the other one, which is okay, we've looked at this. So let's look at polymorphism. So polymorphism is an object-oriented programming concept that allows objects of different classes to be treated as objects of a common superclass. It enables the same interface to be used for different underlying forms, right? So in simpler terms, poly means many. Like polymorphism allows methods, and morphism means forms. So polymorphism allows method in different classes to share the same name, right? Look at it. Polymorphism allows method in different classes to share the same name but have different based on the class implementation, right? But in other programming language, right, there, okay, in this key feature of polymorphism, we have what we call method overloading, right? So now this is what we mean by method overloading. Multiple methods in the same name, in the same class, with the same name but different parameters. And Python doesn't support this. Let me show you what's called method overloading, right? In some programming language, let me just use another script to show you method overloading. Let me just call this um form.py. So let me show you what is method overloading. Let's assume that we have a method called add number like this, and we have a parameter like a b, right? So now this function, this method is returning a plus b. Now we also have another method called add number. Now this method has parameter a, b, and c, right? So and this method is returning a plus b plus c. Now Python does not support this, right? But in most programming language like C sharp that I've been using for years support this, right? We support this. We have same name, same method name, but different parameters. We support it. Python doesn't support it because if I'm printing the last one, we override the first one, right? So if I'm printing, that's what. So if I print add number, so if I pass in an argument like 34, right? So if I print this pi form.py, it gives me an error because I'm missing one argument because this one will override this. So I need to put in another argument for my function to work, right? Right, you can see what happens. So this Python does not actually support this. So what Python supports here is method. This is method overloading. Python does not actually support this. So what Python supports is method overriding. A subclass can redefine a method from its parent class to provide a specific implementation, right? So in the type of polymorphism, we have the compile time polymorphism method overloading and the runtime polymorphism method overriding, which is supported in Python. That's what I'm going to show you guys here before we end this OOP class, right? So every other classes I'll be doing will be on other examples for other examples on OOP, which we'll be looking at many examples so that you can be able to understand it better. Now let's look at how we can be able to implement polymorphism in Python, right? Good polymorphism. So going back to our OP, where we define our animal here, right? So we have defined a cat, which a cat can walk and a cat can make sound. Now let me copy this, right? I'll copy this and I'll paste it here also, right? Now I will call this class now. I'll call this one dog, right? So the same thing, dog has a constructor and then is inheriting the parent constructor, right? So we have the describe. Now this is an example of a polymorphism, right? This is an example of polymorphism. You can see we have two subclasses and these subclasses are described and also this other subclass called dog has described. You can see they have the same name but they're doing different thing. They will do different thing but they have the same name. So this animal walk is also in the and is a method which is also found in a subclass called cat, and then the animal sound is still the same thing. So if I go to this test.py, right? So what? Let's try something. So if I print, now let's have a variable called dog, right? So we have a class called dog. So I'll pass in the argument here. I'll call this dog 2. Then let's say dog make woo sound, right? Woo. So if I'm printing this, so it will be dog dot animal walk. So let's see what happens here. Okay, so let me print it's supposed to be pytest.py. So you can see the cat walks like a cat, the cat makes meow sound, the dog walks like a cat. Okay, the dogs, let's change it, the dog walk like a dog. Okay, so let's run this again. Now, the cat walks like a cat, the cat makes me sound, the dog walk like a dog. And if I want to add another extra function here, now print dog dot animal sound. Okay, so if I'm printing this, you can see the cat walk like a cat, the cat makes mew sound, the dog walk like a dog, the dog makes woo sound. Now you can see that they have same function, but they are doing different things, right? So this is what we call polymorphism. So we have understood abstract encapsulation, we have understood abstraction, we have understood inheritance, and we understood polymorphism. You can see how we define all of them in just one code here, which I'll be giving you guys example to do this yourself. You can see how it's very simple. Now there are so many advanced stuff which I will give you guys in class to write, right? So that you can be able to have neat codes that we can be able to use your code very, very well when you implement the OOP in a very special way. So I believe that this video enabled you to understand what abstraction is, what encapsulation is, then what polymorphism is, and inheritance. So thank you and God bless you.